My background is in product design, so I was a professor of product design for a long time, and so everything that you've been involved in, particularly like at Sheffield Hallam, that's really sort of my background. And then I made the move at the beginning of this year to actually go from being professor of product design. I've moved to another university. I've moved from the design school and being in the #1 design school in Australia to going into an engineering school, which is quite different, quite a different experience, to be professor of additive manufacturing. And this was a very specific decision, and it was kind of money where your mouth is time. I remember Steve saying to me, "You're banging on about digital technologies and how 3D printing is a catalyst for change. You've been banging on for years and years, and I'm not seeing the evidence of it." And I'm saying, yeah, look at this, but they're very isolated incidents. So how do we change to a kind of more systems approach? And so that's really the challenge that we've taken up. So we're developing a team at the university in proactive living, which is essentially around 3D printing. Now, 3D printing, to me, like over the last 10 years, I got very excited about its potential for sustainability, because who doesn't want to move from mass production to print on demand? I mean, really should be, but goodness me, it's an incredible uphill battle when you're talking to industry about that. And then in terms of design for health, the potential is just huge. It's integrated with other digital technologies. It should be very fundamental to the practical application of how we design for health. And yet I'm not seeing necessarily the evidence of it. So this is a challenge within the context of what we've been talking about yesterday and the workshops and complexity. That's really what I wanted to talk to you a little bit about today. So who's used 3D printing? Who's heard of 3D printing? Put your hand up. Yeah. Everyone? Yeah. Who's used 3D printing hands-on? Who's actually used a printer? Great. So there's probably quite a few that will have looked like that. Yeah? Okay, so that you're familiar with that. So who's used any other type of printer? Who's used an industrial printer like that? 1, 2, yeah. I know you have. 1, 2, 3. Okay, so we're changing the numbers, aren't we? Right, and there's a big reason for it. You know, something like that's $1,000. A metal printer like that's $1.5 million. A polymer printer is about $190,000. So it's a big shift in thinking. So in terms of how we discuss 3D printing, one of my problems is most people are thinking about the little desktop. And when they think about it as widgets and small things, and in terms of using 3D printing, the standards are not very high. And so that's the first thing that we kind of got to get across. We've got to get past that. Then the understanding of where 3D printing, how long it's been around. So stereolithography and the use of SLA in the design of skull implants, for instance, been around 30 years. This is not a new technology in that sense. And yet, again, our understanding of it is really not matured. If you look in industry, what's happened, the exciting thing is in the last 10 years is that we've used for mostly prototyping and resin-based materials. We've now moved into industry where these products are being used in end-use materials. So that's a huge shift, the last 10 years. So this is an example, seat brackets, topology optimized. We've got 8 components into one part. It's 40% lighter. So in industry, there's a drive, particularly in aerospace and in automotive. And if you've flown on an Airbus A380, you've already trusted your life to 3D printing. There's over 1,000 metal brackets in that particular aeroplane. And so there's a big drive in that industry. And so what's happening in the medical industry, you know, we hear of one-off things. Fantastic examples, hip joints, for instance. If you're not familiar with it, hip joints usually come in sizes like your shoes, 5, 6, 7, and 8. And if you're a 5.5, well, surgeon's going to have to chop a bit of bone off, or else you're going to be walking a little bit funny until they can get a size that fits you better to come in. So there are kind of issues with the current system at the moment. One of the things I would say about that kind of move to the personalized hip joint, for instance, is that it's been shown then there's a reduction in the amount of times that people have to come back for further surgery. So if we could get that right, that's really good. Then we're also seeing the use of 3D printing, again, high-end 3D printing in orthosis. So this is using a multi-jet fusion 580, for example, when you can create personalized orthosis. Fantastic use of it. So, but why are we not using it more broadly? Why is it still a bit of a niche thing? And one of the issues is that these things are not easy to use. It's not straightforward. It's not a push-button technology. We're not talking a desktop printer. We need to develop a workforce that's really savvy about these things and can use them with a high degree of complexity. And actually that's not happening in education to the extent that it should be. And the development of materials for health needs to be promoted. We need to invest more in it. And one of the reasons is that there's over 45 different 3D printing technologies at the moment. So again, when somebody says 3D printing, they've got something in mind, and actually it might be a completely different technology that's appropriate. So we have to really understand that a lot better. So that's a challenge that we have to overcome if we're going to use it properly. And then the other thing is, people have this idea that it's a push-button technology, and often if they are using high-end, they'll use an online service provider, or they'll send it to technicians who don't necessarily let you know exactly what goes on. But I can tell you that working with metal printing is not some automated clean thing. It's actually, you know, you're going to break your nails working with this stuff. It's really not as automated as we think. So if we want to work with it, we have to be real about that stuff, and a lot of the time that's kind of hidden from us. What we are seeing in product design is the use of 3D printing in preventative, in some really good examples. For example, in terms of ergonomic jigs, that kind of thing within assembly line production, those kind of preventative measures, additive manufacturing is a really good technology for it. So we're kind of seeing it at that level. But if you think about some of the workshops yesterday, and we talk about complexity and systems and things, relating that to 3D printing isn't discussed very much. So that's really what I wanted to move on to. So, for example, we have here Ziggy. This is a puppy that we worked with who had been run over when it was young, and a vet wanted to make a correction, perform surgery to improve the strength of Ziggy's remaining leg, which had also been run over. So what we did was we took CT scans, very simple procedure, created a model, printed out 12 of the bones so that the vet could plan the surgery and decide what they were going to do. As part of that, we were developing surgical guides which basically say, cut here. Yeah? So you practice the surgery, you get it right, develop a surgical guide. Now think about the implications of that. That's happening more now. In fact, the demand for surgical guides, certainly in Australia, is going through the roof. If you've got a surgical guide and you can say, cut here, you take that planning away from it happening actually within the surgery itself, at the point where the patient is opened up. What's that going to do in terms of developing a future workforce? Are we going to then create people who are not conventional surgeons who are going to be able to do this particular type of surgery because we've done the planning in advance, we're providing those surgical guides? Are we going to say that we can work remotely in this kind of way? So there's quite a resistance to the idea that we might actually be changing the workforce and changing who's able to do that kind of activity based on this sort of thing. The other issue we have in terms of surgical planning is, at the moment, is that We see some fantastic examples. This was done by a surgeon in the US who was working on a fetal surgery, and he was doing surgical planning for that. But again, to actually design and print this, to get this together and print it effectively and use it as a surgical planning tool, you really have to have a high level of understanding, right? Are we going to train our surgeons to do that? To me, it's just not going to happen. It's very unlikely that we're going to be able to get surgeons to be able to operate universally at a level where this kind of thing is effective. So we have to recreate the system. We have to design a new system of collaboration that allows designers external to the hospital, external to that particular discipline to work together. And that's a very different way of working that's happening now. The other thing in terms of systems, which I think is really interesting, is to look at what happens in GE Additive. So GE, General Electric, they saw what was happening with Additive. They split the company into two, and they develop products. GE Additive develops products for aerospace. So this is a good example. This is their most recent one. So they took a turboprop engine, they consolidated 855 parts into 12. So you think about that in terms of assembly and in terms of weak spots and things like that. They had a weight reduction, fuel burn reduction, their testing was reduced. Looks good, yeah? What they hadn't appreciated, what they hadn't expected, and was actually came as a real shock to them, was the impact on their whole activity. So they were thinking of it very much as a one-off product, and they hadn't really appreciated when they first started that the main impacts were going to be on the system, the whole system that was behind it. So 300 files were reduced to 1, 60 engineers reduced to 8, 50 manufacturing sources reduced to 1 inspection system repair sources 5 to 1, data systems 40 to 1, right? This was the unexpected outcomes of it. And so now their research is all in how do we recreate, how do we look at the systems, how do we redesign our whole business model in order to address that kind of thing. And so my argument is, in design for health, we're in the same situation. Everybody's looking at one-off products in terms of 3D printing, and it is kind of marginalized when, to me, that whole 3D printing, digital technology, associated digital technology has such a massive potential to impact design for health outcomes for patients, and in terms of cost. Cost is a really big one, but we're not doing it because we're not thinking of it in a complex way. We're only thinking of it as one-off products, and we're not thinking about the systems. Paul D'Urso is one of my heroes. He leads a company called Anatomics, and he's been a leader in this field for a long time. This is a titanium rib cage that he printed for a patient in Spain. Of course, you can do the file here. You can have it printed overseas. There's absolutely no problem, as long as you've got the system set up to make sure that it's all calibrated properly and that the testing's done properly, that the printer works properly. Now, with this kind of thing, what's happening is that someone like Paul D'Urso is a great example of that. He talks about the smorgasbord of surgery, whereas in the past he would have every possible plate and screw and surgical instruments he might want to use within a surgery. It would have to all be sterilized and bought in. The nurses would spend a lot of time doing the inventory, getting it all ready, massive expense. He'd go into the surgery, open the patient up. The patient might be on the table for 4 hours, 6 hours, while he decides how to build whatever it is he's going to put in there to fix the problem. The patient's under anaesthetic for that time. The theatre is being used for that time. All the costs associated with that and all the risk that comes with that as well, because he doesn't know what he's going to find. Then he has to sew the patient up. Everything has to be taken back and put away, right? Now, what he can do is he can literally design he does a print of the say it's a spinal thing. He does a print of the spine. He designs the particular plate that's going to go in, which will be 3D printed, designs the instruments, because incidentally, surgeons always hack their instruments. They always have to create them specifically, adapt them for particular surgeries that are involved. And then all he has to sterilize are literally those instruments, the plate itself, any tools that he needs, and he said he estimates around 7 things, and the patient will be open for 20 minutes on the table. We actually need to do this. We need to really embrace this seriously, because costs are going through the roof. We can't allow the kind of the practice, the business as usual, to stop us from embracing the opportunities that this kind of technology allows us. And I really encourage you not to marginalize this and not to think of it in terms of these little fused deposition modelers, but understand the potential impact that 3D printing and associated digital technologies can have on future practice, on costs and patient empowerment and patient outcomes. But we really need to put the work in and understand it properly. The future can be very, very different, but it won't unless we put the research into these things, very specific technological and systems thinking that we need for the future in order to make that difference. The complexity here is not free. It's incredibly complicated. It's not going to be sorted out in 5 or 10 years' time, but it would be really great to start that journey now. So yes, the complexity is not free, but I would argue the cost is very much worth it. Thank you.